Yeah, so like Jen said, I work for a local consulting group. I actually have an educational background in political philosophy and art history, and I worked in a state, family, and real estate law firm for a few years. So I'm coming at the topic of ML and AI from perhaps a slightly different standpoint than just purely technical. I'd like to talk about some of the ways that like human bias gets translated into like AI settings, into machine settings, and then the kinds of mitigations we can like do to deal with that problem going forward. Someone told me that they weren't sure what my talk is about, so it's those two things: where it comes from, how to fix it. I have two laptops to manage. So just to start from that kind of philosophical level, there's this concept of mathematical purity, right? So like 500 BC, Pythagoras says that numbers are the basic element of the universe. It's like very early atomic theory, and everything can be mathematically represented. And since then, in academia, in all sorts of scholarship, that's basically been kind of like the prevailing theory as far as math goes and the hard sciences go. We still see this all the time in STEM education. This is objective, this is true. And the concept of mathematical purity has kind of stayed with us and translated into computer science in a lot of ways, right? Everything is binary based on zeros and ones, truth and false, all that kind of stuff. And I think this sometimes tends to reduce our scope as technically inclined people from kind of the gray of human areas and into the black and white of 0, 1, true, false. And then over on the right here, we have the lovely Leopold Kronecker, who was in the 19th century saying, the integers were created by God, all else is the work of man. So he was basically a philosophical predecessor to intuitionism in math. And that just means that math represents the result of the mental activity of humans. It's not a discovery of the fundamental principles in an objective reality. Math is a human tool used to represent like our reality. It's not in itself objective any more than the people who create it are. So just to kind of give you a standpoint of like philosophically where I'm coming from that kind of the normal, or I guess the prevailing wisdom about how we can look at math, at science, at the things that are predicated that like computer science is built off of, and then kind of another way of looking at math as a human tool. So then we kind of get into the history of decision making. So forgive my very, very simple graph. But until like arguably the mid to late 60s, most of the decision making in our world was made by people, right? Like we would want something from a bank, say, we would want a home loan. And we would go and we'd talk to a person and we'd tell them about ourselves, and that person would make a decision. And human bias gets in the way of that all the time, usually along the lines of prejudice and what, like in the US at least, we call protected classes, right? Gender, race, sexual orientation, religion, national origin. And then around the 90s, our focus shifted to computer decisions, right? Basically really complicated if-else loops where you put in inputs and it would go through a predefined flow. And then at the end, the decision would be made by whatever like computational flow we had decided on. And then more recently, we have AI, and more specifically, in a lot of cases, machine learning, where we have an input and it goes into essentially a black box that is a model, and then we get an output. And there's nothing necessarily wrong with this, but there comes a question, okay, what happens when we discover bias in each of these systems, right? How do we address it? And with a person, you can fix the person, right? Or you can fix the tools that you give the person, right? So you can say, we're going to retrain you, we're going to fire you, we're going to hire someone to do better work with you, we're going to give you better actuary tables, whatever it is, right? You can do a lot of things to fix the person bias. But with the kind of if-else loop, you can go in and weight things differently. You can add new inputs. You can take inputs out of it. You can do a lot of things if you know what the computational path is to deal with any discovered bias in your system. But with machine learning, this becomes really hairy because basically what you can do is retrain the model and hope it works. And this becomes really, really difficult in a lot of ways if you haven't already worked some methods into your systems of using ML and like AI generally. And I'd like to get into kind of talking about how we accidentally feed like how we accidentally give bad data to machine learning models or biased data and result in horrible outputs. On the left here is a map of Denver in the 1930s. You'll notice there are colored sections. That's because this is a map of what's commonly known as redlining. So this was very common in banks up until the 1960s with the Fair Housing Act. And basically it said that we will not give mortgages to any of these red sections, probably won't in these yellow sections. Green sections are the best, blue, okay. And unsurprisingly, the red sections are mostly black neighborhoods, the yellow sections are mostly other minority neighborhoods, and then the blue and the green are mostly white neighborhoods, at least in 1930s Denver. And then on the right, you can see Denver property values in 2015. And I hope that's like fairly clear. There are obviously different maps, the cartography has changed. But the property values map really, really closely to this legacy of redlining, right? Where people were able to buy houses, where people were able to get mortgages, where people were able to accumulate wealth, so too did neighborhoods like flourish and succeed in a lot of ways. So when we talk about like the legacy of redlining, you have to conclude basically that home ownership is probably a really poor metric for deciding a lot of stuff without introducing bias into your system, right? There's so much that's ingrained in our history of housing and financing and wealth accumulation in America that almost any model that includes housing as like a large part of as a large like weighted factor is going to turn out probably bad. At least as far as racial parity goes. So then we get into the question of like the outputs of machine learning systems, right? So there are basically two major pitfalls. There are more, but these are the ones I'm going to focus on. It's false positives and false negatives, right? Fairly simple concepts. False positives is saying, yes, this is definitely a thing and it's not that thing. So on the left here, we have an area that's highlighted in an imaging in I believe a CT scan for a potential cancer cluster. And this has been actually, machine learning has been really, really useful in image processing for diagnosis in the medical community because the machines are much more likely to give false positives for this sort of imaging. Like, this is definitely cancer. But in this situation, we have a human in the loop, right? There's a human pathologist who goes and looks at whatever the computer is flagged and says, yes, it's cancer. No, that's a cyst. Hey, maybe this is cancer, but computer, you're totally wrong. We don't need a double mastectomy. We need maybe some radiation and follow-up treatment, right? So false positives is when you, just something is overblown in that sense. And then we have false negatives, right? And false negatives that say, you don't need to worry about this, it's totally fine. And actually it is a problem in whatever sense. So in the case of cancer, it'd be if the machine missed a cluster of cells. In the case of what I'm about to talk to you next, it's basically determines how harshly someone gets sentenced. So some of you may have heard of COMPAS. It is a algorithm which is used in a bunch of municipalities across the United States, mostly in police departments, to assess like the risk score for recidivism. Recidivism being reoffending after someone has been like convicted of a crime. In these images down here, we have two different people. And the gentleman on the left, Dylan Fugit, whatever, he, before he was booked for a crime in Florida, I forget which county it was, he had past offense of 1 attempted burglary, and he had a low risk score of 3. And then he went on to be convicted for 3 separate drug possessions. And the Bernard Parker on the right had 1 prior offense, which was resisting arrest without violence, basically talking smack. And then he had a higher score of 10 and went on to not reoffend as of like 2017, I think was when that article was last updated. So COMPAS was found in 2015 by ProPublica to have an extremely weighted bias for false positives with Black people and false negatives with white people. So that's to say that a Black person is much more likely to be flagged as high risk, and a white person is much less likely to be flagged as high risk. And The reason I started with housing as an instance of bias is that one of the heavily weighted factors in the Compass algorithm is home ownership. So we get into this state where if we aren't thoughtful about our inputs, then we start to get outputs that are not trustworthy. And in cases like this, right, in cases where I believe Mr. Parker had a pretty harsh parole sentence and was ended up in prison for the maximum sentence term of what he's convicted of, which I'm forgetting, I should brush up on this, whereas Dylan Fugit wasn't, right? So this has like real world impact on people, how long they spend in prison, like what goes on their record, what sort of terms they need to adhere to in their parole sentencing or in their parole once they're released. And yeah, and this is not the only case in situations like this. Like I said, these two people were from one county in Florida, but Compass is currently used in hundreds across the country. Even after the ProPublica, actually their sales increased off of the backs of that expose, which is kind of depressing. So that's kind of a way to contextualize the inputs and the outputs. And I'd like to move on to solutions because there's only so much you can do when you're like, oh my God, that's horrible. What do I do, right? So solution one is people. And I just have the one chart up here to talk about like the pipeline problem, because I think that's a pretty like common thing that people talk about. Oh, like we can't find like people of diverse backgrounds. It's really, really hard. But actually representationally wise, white people have a smaller share of CS, while Asian people have a proportionally higher share of CS. And Black and Hispanic populations are only marginally lower than their actual representation in the population. So when it comes to hiring and recruiting, the pipeline problem is mostly a myth. So just to kind of give a very quick rundown of why, like how, I guess like proof for people being a really powerful solution to issues of bias. There is a woman named Michelle Kim. If for those of you who are interested in further reading, she's very vocal in like Medium and Twitter, and she's a D&I consultant. So she goes and works with companies to increase their overall diversity and inclusion programs. And in 2018, she compiled a series of studies dating from about the mid-90s that focused on diversity initiatives and the outcomes for business. And I've read those and a number of citations from those papers, because a lot of them are meta studies, and numbers-wise, here we go. Okay, just brace yourselves. Companies in the top quartile of diversity are 35% more likely to outperform industry revenue averages. Companies with the highest level of diversity make 15 times more than companies with the lowest levels of diversity across industries in mid to large size businesses. With metrics like employee satisfaction, customer service, and product innovation, highly diverse companies receive an 83% boost to all of those. Diverse companies are 70% more likely to capture new market share and bring new ideas to production. And if the team responsible for developing a product has a member of the target demographic, that product is 158 times more likely to appeal to the demographic. So there are pretty considerable business cases for taking people seriously, and also for understanding the context in which whatever you're making is being used. And that's been carried out and studied time and time again for the past 25 years or so, basically since affirmative action was something that people wanted to study. And there's tons of research out there to go and investigate if you're curious. Then, in case you guys haven't seen this. Oh, no sound. Okay.
No, because we're good.
Oh, okay, yeah. So it's still pretty self-explanatory without the audio. So, this kind of thing maybe says something about the company that made the soap dispenser, the company that bought the soap dispenser, whoever they brought in for testing the soap dispenser, because presumably they did do some sort of customer study, does this work? Yeah, it reveals a pretty like appalling lack of diversity along the entire supply chain from when this was made to when this was sold to when this was actually used. But if you start to think about the difference between skin color in a diagnostic context, like going back to cancer diagnosis, the medical community is kind of notoriously bad at catching early stage skin cancer in Black people. And because it is so frequently caught in later stages, the mortality rate for Black people is much, much higher for skin cancer than it is for white people. Imagine we've trained an algorithm to diagnose skin lesions and suggest whether they're cancerous or not. Since our own medical community rarely catches early stage Black skin cancer, we may not have very many images available to train our model on. We may not be able to give it a lot of early stage examples of what it would look like on a Black person. And so we get into this situation where it's difficult to access the data. We have a biased data set because we have so many more examples for people with lighter skin than people with darker skin. And then that kind of bias, that inability to detect early stage skin cancer in people of color, ends up becoming a bias that's passed on to a machine learning model. And this is not just relevant for issues of skin color. There are tons of instances of this with genetic markers that are specific to very small ethnic communities like across the world. So this is a sort of thing where if we have a lack of genetic material, or if we have less studies done on certain populations because there's not much medical research in a certain region, then this has the possibility to perpetuate across like a lot of different groups and in a lot of different ways. So the second solution is institutional values. In 2015, I believe it was, Intel announced that they wanted to meet a certain goal for their D&I initiatives. They wanted to increase they wanted to get closer to parity, and their goal was to get to not 100% parity, but to like 50% parity between like major ethnic groups in the US and their actual hiring metrics. And they got there in about 3 years. Google announced a similar initiative. Sorry if there are Googlers in the room, but yeah, they announced a similar initiative in like 2011, and they're actually worse today than they were in 2011. So it comes into a question of like, okay, well, what's the difference between Intel and Google when they were approaching this problem? Like, what kind of resources were they putting into this? Where was their money going? How was their hiring incentivized? What were the institutional values that drove this change at Intel versus at Google? I'm not saying Intel's a great company. There's some weird, shady stuff in their background, but in this particular case, you know, there's a pretty stark difference in a company of similar scales, that one that was able to do and achieve this goal in 3 years, and one that is worse off than it was about 8 years ago now. The third solution is math. Yay, math. I am not a statistician. I took calculus in high school, and that was the last math class I took. So when it comes to the technicalities of this, I can point you to papers if you are a math person, but I do understand conceptually how this stuff works. So the first option is adversarial debiasing. So this is where you want the model to guess two things, not one. You want it to guess the protected class, the sensitive attribute, and then you want it to predict the label, right? So if we're talking about skin cancer, we want to say, hey, can you predict this person is Black, and also whether they have cancer? And every time that that the model is able to guess the sensitive attribute, we send back a negative gradient to the model, so that it becomes trained to disassociate like any information that it might pick up on to create like basically a biased output. So that's the first math approach. The second one is dynamic upsampling. So for the example of potentially diagnosing skin cancer, if we have a much smaller data set for early stage skin cancer in people of color, then we might say, okay, we are going to statistically spoof some data and increase the representation of an underrepresented group in our data set, so that they start to have equal weights in the model going forward. And there's a third one, which is a little shaky to me, which is why it doesn't have this like, little image here. Distributionally robust optimization, which rather than like minimizing an average for a certain population or improving the empirical average, it looks at the actual groups. So you do give it the input of whatever you're trying to debias for, and then adjust for the loss of accuracy as you give your model more and more data to train on. Because over time, so say we're doing the skin cancer thing, over time, the bias will increase as we give it more early stage white patients versus early stage Black patients, and dynamic distributionally robust optimization seeks to try to correct that through statistical maneuvers that I don't understand. So yeah, that's one potential solution, math. The fourth one, I think everyone in tech hates, but regulatory measures, bringing the government into it, making it law that you have to do certain things if you're going to use AI or ML models in your data or in your business prop. Actually, there's legal basis for this. I think pre-legal is a term that many of you may have heard if you have friends in San Francisco. The concept of, well, there's no law on it yet, so we can do whatever we want. There actually there are laws about bias, and there are Supreme Court precedents. Most commonly, these are referred to disparate impact as disparate impact. And there is a rule which is commonly accepted legislatively and in the courts called the 80% rule. So adverse impact basically is a practice that appears neutral but has a discriminatory effect on a protected group. So it can, the first time this really came to court was in 1971 in a case, Griggs versus Duke Power Company. And basically there was a job listing for an entry-level position for maintaining cable lines with this power company. And the minimum requirement for hiring was that you had a high school degree. Now, this was 1971, so Black people did not generally graduate from high school at that point. So it turned out that actually they just didn't hire any Black people, and the people who did apply for the position were not selected because they didn't meet that minimum threshold of receiving a high school education. So that's adverse impact, right? Where you didn't say no Black people need to apply, but you did produce a barrier which means that people can't actually get into that position regardless of their ability to do the job. And so that 80% rule means that 4/5 of people who are otherwise qualified should be able to get in. And even if it's unintentional bias, even if it's not an intentional policy to exclude certain groups, that past that 4/5 area, you're still able to be held liable, and you should have realized that this was a discriminatory practice and have addressed it. This has come up before the Supreme Court several times in 1978, in 1981, in 1991, and it's been upheld every single time. And currently, though, there have been some Justice Department memos floating around, and under both HUD and the Department of Education and the current administration are seeking to find a legal path around this kind of precedent. And there's a potential for that regulation to be rolled back on at least a federal level and perhaps on a legislative level. So the other thing that's really relevant in the context of machine learning and AI is that the Trump administration has sought to basically say that if race wasn't explicit or the tool that was found to be biased was provided by a third party, that whoever was using that tool cannot be held liable. So if we are talking about things like Compass, which is being used by hundreds of municipalities all around the United States and producing truly biased results that's impacting all sorts of really negative life experiences for the people who get false positives and false negatives, then those municipalities, under this sort of suggestion that's been floating around, would not be able to be held liable for that, using those tools. So this is actually under start right now, and I think it's a big deal, so I'm bringing it up. And then there are important caveats, right? So we have all these ways of addressing things, but there are limits to this. Just because an algorithm is fair doesn't mean it's being used fairly, right? So With Compass, for example, it's been used by judges and police departments, but also in a couple of places it's been used by social workers. And social workers have used this and said, oh, shoot, this person needs a lot of support and they need a lot of access to services. I'm going to make sure, because they have this high risk score, that I'm going to support them more actively. And so it's actually produced really great outcomes for some people who have more access to the system and have a more engaged social worker because that social worker believes they're at risk of recidivism. So it's not necessarily that, I mean, just assume Compass is not biased for a moment. It's not necessarily a horrible thing that like a social worker would have access to some sort of metric which gave them an idea of how much support someone could need. But giving that same metric to a police officer or department, to police communities, or a judge who's deciding parole and prison terms might actually be truly negative. So it's not just, is this algorithm biased? It's, what is this algorithm being used for? The second caveat is that the current methods of debiasing are mostly predicated on having access to large amounts of data, right? All of our machine learning and AI, like, consume huge quantities of stuff. This is ads and recommendations and I don't know, like like financial tools, credit scores, all that kind of stuff. There's so much data to be consumed, and that's kind of the system in which ML has been developed currently. But there are so many areas in which data is rare or expensive or difficult to produce. Military settings, for instance, medical diagnosis, all of this kind of stuff where it's actually quite difficult to source data ethically and legally in some cases. And where that means, like, our current machine learning models, which rely on a certain amount, a certain scale of data, are not going to work particularly well in any case. So it's not, is this algorithm biased? It's, do we even have enough data to create a good model? And then third, AI doesn't solve its own problems. At best, it offers excuses for why it happened. So, you know, you can have explainable AI where it tries to tell you where it went wrong. Oh, this image was like poor quality, so I didn't know what to do with this, and then I messed this up, and it highlights the areas where like it got confused, right? That's about the best of what we have for an AI model being able to self-correct. But it's not actually able to go in and select its own data and relabel its own data and like make those sorts of changes that require human intervention. So yeah, that's an important limit for understanding how far ML and AI can go, at least in the current paradigm. And fourth, we still haven't decided who's responsible for the mistakes of AI. I attended a talk a little while ago given by someone who works for DARPA, and they said that DARPA has poured a ton of money into AI over the past several years, and no one will touch it with a 10-yard stick, because in the military, for strategic decision-making and strategic orders, you have to sign your name to a document saying, I gave this order. And in AI, there's no sense of responsibility for where that comes from, and people are very uncomfortable giving their seal of approval for something that was generated by a machine. Especially when we're facing the problems that we were talking about earlier, where there's limited data, right? There's only so much live combat that you can accurately record and then feed into a model. And at the end of this talk, the gentleman, his name is Baxter Eves, suggested to the room that perhaps programmers should be held responsible. And otherwise, during the talk, people have been clapping and laughing, and it was dead silent. But I do think that's a very viable solution. I think that the solution to these problems are you, or me, individual contributors all over the place. Because ultimately, bad models can't be written and can't be used if programmers won't write it. So ultimately, if all of their solutions have failed, right? If we don't have an impactor group we can see that we can turn to for auditing, if we don't have the mathematical expertise, if we don't have regulatory measures that prescribe for us how we can approach these problems, if we don't have an institutional value system backing us up in each of these situations, then it comes down to us and whether we choose to write the thing or not. The programs we write aren't like aloof arbiters. Like we are writing them, and we are telling them what to think and how to do things and deciding whether they're good enough. And I go back to the concept of mathematical purity and Mr. Leopold, and math is an indifferent tool, and it's not a source of truth. And we're responsible for making the best possible choices that we can with the tools that we have. And that requires a sense of responsibility from those who are using it. Yeah, so that's my spiel.
Cool. Do we have questions?
Like 5 minutes.
Yeah, 5 minutes questions, 10 minutes questions.
Yeah.
So before you gave all of these solutions, you kind of answered my original question. It was like, where in the machine learning pipeline should like the best place be to intervene? And it seems like all of these 5 solutions touch different parts of that pipeline, from gathering the data, processing it, feeding it to the model, assessing the model, and then deploying it. So it's like basically touched all of them. But do you think there's room for like maybe the pipeline as we're using them could have like be expanded to have other things inserted in there?
Yeah.
So like, for example, for like the housing, a lot of banks will use these programs to evaluate whether someone should get a loan, and like they just say yes or no on that. So what do you think about like expanding what that pipeline looks like, and what could that look like?
Yeah, so I'm, again, not really a mathematical expert, but everyone I've talked to who is says that the best place to intervene and is like extra steps in the labeling of data, and not just feeding raw data into systems, expecting them to do well. It's kind of like why every Twitter bot under the sun turned into like a Nazi in like 24 hours. So, because it was being fed bad data. So everyone I've talked to has advocated for that as like really the place to focus efforts. Of course, people don't really like that, because that's people. You need data scientists, and you need labeling, and you need that to be done by hand by a person with some discernment in the training data set. And that's very people intensive and time intensive and cost intensive. And a lot of the people who are seeking to leverage ML and AI don't necessarily want to invest in people, because that's against the point of using ML and AI for a lot of industry thinkers, I think.
Yeah, it seems like maybe the companies building for like the housing one, for example, they would maybe lose a percentage off their bottom line if it was more fair. So like getting them to be okay with that is another hurdle to overcome.
I genuinely think that probably in order to like get to a meaningful place where like we don't enter a really nasty paradigm with AI and like the subsets, probably involves all of these approaches. I think the government regulation is going to be really key at some point. It's just unfortunately the government is so far behind tech all the time. But I really genuinely do think it's going to be a mix of technical approaches of people being really invested in what they're working on, and then the government stepping in for those who aren't, to be like, no, do it. So
I hold a little hope for the fact that there have been 2 other eras in the computer industry in which AI was hyped as going to solve all the problems, and it just disastrously failed. And so I feel like we're in another phase of, oh, maybe we've really figured out how to do AI, and we haven't. I think we grossly underestimate what humans do with our not artificial intelligence. And so
part of why I find this topic so fascinating, despite my lack of like mathematical background, is that I think society chooses itself in a lot of ways. And I think we're kind of like in a space where we're about to choose how much we rely on these tools and how key they become to like what we do as like businesses and societies. And I'm like really hoping we choose to do good things and can choose to pay attention to this change that we're making. And yeah, so that's why I'm giving talks on it.
Any other questions?
I don't know about you guys, but more and more I find that the ML things that I use in my projects are SaaS products or products that I'm consuming. These things get built in-house by generalists less and less. It's data scientists and other specialists building these things. So as a person picking a product off the shelf, you have any suggestions for how we can evaluate and try to find these negative cultural biases in these things before we buy them?
God, that's so, that's so hard because it just depends on what you're doing, right? Like it depends on like, are you consuming a bunch of like what people clicked on and using that to drive ad revenue? Because there's scale, right? There's like, do we really care if we mess up on recommendations on Netflix? Like probably not. Like, do we care if we mess up on like cancer screening or how much jail time people get or like what our guns shoot at on like battleships? Yeah, we really care, right? So it's kind of like a sliding scale in between there. And I wish I had like, I wish I could tell you just like a way to do it, but I don't think there is a way because it depends so much on like the data that you work with. Yeah, I'm sorry.
Should you ask questions?
Yeah, definitely. Ask questions.
What kind of questions would you ask?
I mean, I would honestly ask like whether they do any of these technical approaches, like whether they have an internal audit team. Like, I think it's really weird that there's not like ethics departments at most tech companies. Like, I mean, especially the really big ones. Or I had a friend who worked at like Facebook's kind of like community, like integration, like caring about people thing, and they had no executive authority over anything. So things could roll out that they thought were deeply unethical and problematic for the community, and they had absolutely no sway over it. So I mean, kind of, I think it's a little mix of everything, right? Because all of these different things go into it. So how willing people are going to be to answer those is like a completely different question. A lot of, unfortunately, something I forgot to mention was that it not only does it go into a black box, but if you're consuming it as like as a SaaS service, then like, you know, it's proprietary and you don't have a way to audit necessarily. You may not be given the tools or the access to be able to really check any of this stuff on your own, and that frightens me in some ways. So I wish I had a better answer, but it's just, I'm scared.
It seems like if we're the consumers, though, we can be asking these questions to let the vendors realize that we care about that as a topic.
The fact that they don't have an
Create
audit team
demand.
might be a signal.
Exactly.
Right? Like, oh,
Exactly.
they don't.
I think, you know, what's your head count for the people annotating your data before you feed it to your algorithm?
Right.
So we put pressure on the vendors.
Is there actually an algorithm or is machine learning a
more
marketing
and more
term?
data, right? It becomes almost impossible for a human auditor to parse through billions and trillions of images and say that this is actually going right. It's more of a, it seems to me, it's more of a train it, look at it, wait for the bad result to come out because you actually don't understand how in depth it's analyzed something and made a misrepresentation until it's out and it's doing its thing, and then you're like, oh, look at that, this you know, in this case it used this model, and that's where it needs to be retrained. So I think that's going to be a thing in the future too, that it's going to be hard as these models get built and run and they consume so much information and ingested it and made up their own choices, I guess.
Absolutely. I feel like part of what we're like, I want regulation to take effect is like for kind of that sliding scale of impact, and that the more impact it has, the more stringent the data input process needs to look like, because there's so many ways. Like, I'm totally comfortable with ads being fed into like a machine learning model and just kind of not being labeled or otherwise processed aside from like, you know, this is my profile, my anonymized profile. It's used this way. Train, right? Like that's fine to me. That's not like a really scary prospect, but it's when we get into like, maybe we only have a couple thousand images for early stage like skin cancer, or maybe like 100,000 even, like, and then we're using that to make medical decisions about the care that people receive and like whether or not they're identified as like at-risk patients, where I'm like, there should be a human in that loop. I want a human in that loop. And we do in a lot of cases. And there's like that secondary layer of human auditing, right? Like, where if a machine can say, I think this, and then if it comes to individual impact, and then a person can audit it and say, oh no, I disagree, which human pathologists do all the time with like cancer screening, is they get like some like images that have areas highlighted by the image processing models, and then they decide like whether or not they need a biopsy, whether or not it's a cyst. You know, they can do that kind of troubleshooting, that more like variant thought, I guess you might call it, that humans can do that we haven't quite figured out with ML yet. So yeah, the higher the impact, the more people I want in it, unfortunately.
Cool, I think we're out of time, so thank you so much. 5-minute break, grab another drink or go to use the restroom or whatnot, and at 7:20 we'll be back here to hear Caitlin talk about waffles. Waffles. That was great. Yeah. Oh, you go.
I was super ready for my bureau stuff now. Yeah, I couldn't remember the name of that algorithm. It's one of the best examples of machine learning gone wrong that's used in widespread today. It's like, it's been shown like it's really biased. Like you shouldn't use it. And there's nothing. I didn't know that the sales of it actually went up after ProPublica published that thing. Because I heard about it when it came out like 4 or 5 years ago.
That's horrifying.
Yeah.
Well, obligatory.
So I hit record.
Yeah.
Oh wait, no, it's still recording. I thought I pressed stop.
Yeah, I mean, I feel like the only drawback there.
Yeah, of course.
is
Yeah,
they were saying the quiet for that.
Oh, you're good. They were what?
They were saying the quiet for that. Like that
Go
was,
down there.
that was probably an intended.
You can go right out the door.
Yeah.
Yeah, like the person we saw there resisting arrest without violence.
Yeah.
He was brought in on the home. This is how that goes.
Yeah. So, did you talk to Alexis about the? Yeah. Did she has this meeting. Okay, cool. I just want to make sure. Are you?
Yeah, she grabbed
HR or
it
you
before you-
developer? Cool. Cool. That's fine. Yes, no worries.
Good looking out. But yeah, have you heard about the Apple Card? Okay, so the 2-second version there is that or Apple unveiled their credit card, and people that were identifying as female were getting way lower credit limits with identical credit scores than people that were, male presenting as like, yeah, like we're talking like a difference of 10 times.
Whoa.
Like, yeah.
How did they not? They must have known that that's what the outcomes were. Like, what are you like not looking at what your ML models are outputting? And you're just like, all right, it's done and go. Like,
yeah, and it's like
Family located here, and
I don't know. There's been a lot of like finger pointing, but nobody's tested.
not sure how much fun I'm
What else was that? We
a lot of
that was the
mentoring
most
from like other tools.
thing that I've heard about, like machine learning.
I'm writing that one down.
Pretty strict, like no pair programming.
I think that's another case of like there might not have been
Well, excellent. I can tell you that there's
engineers that were
so we have 12 devs, like I said.
like, okay,
Probably 5
this algorithm works for me. It's probably perfect.
So that's like.
Just reading an article. I guess I got only like
And,
line,
yeah, I mean, I'm just.
so I didn't read the whole article.
I'm super excited. That's what I'm saying.
Self-driving car,
Which is like.
hit a pedestrian, but
I feel like
jaywalked.
it's-
Oh, I did hear about that. Yeah, because it just wasn't even scanning for humans at that point.
It couldn't,
We're.
it was not prepared for the idea that humans don't cross it.
Yeah, so if it sees a stoplight, it's like, okay, look for humans. Otherwise, that mode is just not engaged or something.
I just think about what I do when I'm driving up the hill towards the ski slope. Oh my god. Or like after you get past Georgetown and it's steep and windy and there's one car that you can see is slowing down.
Yeah.
Trying to get around him and there's a truck ahead of him.
Yeah,
All the things I'm looking at to try to keep my momentum.
Yeah.
Watching the cars behind me so
Yeah.
I'm not blocking their momentum.
yeah,
I don't see AI managing just up the hill. Or even
Yeah.
worse, like in front of the high school over here, right? Or in front of the library.
No.
Right. I've seen people click and just go right into the
Yeah, actually, like,
you can tell you're a real Boulder native.
Like, what do you expect?
It's funny because I definitely 2 years ago I was like, man, this is probably going to be a good thing if we get the robots driving cars because he's on their phone. But then I started paying attention to all the things I noticed when I'm driving. Like,
We've been around 5
software kit.
I think that there's definite advantage to some of like the safety assistance kind of things, like the emergency stopping that will break before you can react. But like, as far as letting it take over, I think we're still honestly like a decade at least from having it actually be safe.
So as an insurance agent, I have like a weird thing. It's like those are expensive, LiDAR and everything like that. So what we'll see is like rates go up.
Right, folks.
And the rates going back down. But like,
Let's all
down. Driving, my hands weren't on the wheel and I was in a car crash. Do I have any?
All right. I can't do that with and she should be able to though. All right, folks. So everyone just kind of sit down, please. This is Caitlin. She is Catlin.
Yeah.
Sorry, Catlin. She is a product manager at Circle CI and former founder. And yeah, he's going to talk about an MVP alternative.
Cool. Yes. Thanks, Dan, for having me. My name is Kate. I like attention, so by all means, shoot at me. And I will try not to talk too long because I'd much rather just have a conversation. So prepare your questions, heckling, pun jokes, via pun jokes along the way. If you have questions, feel free to raise your hand, but I'll try and leave plenty of time to chat at the end. Sound good?
Yeah.
Cool. Oh, I thought you already had a question.
No.
You have 2 first names, if that's what you were going to ask. All right, cool. So we'll talk about what's an MVP, what's a waffle, how to make one, when's a waffle, how not to get burned.
So many puns.
I like fun jokes. This is a blurry picture of me. This is what I actually look like. I'm a product manager. I was a former Ruby developer and Android developer, and then I was a former salesperson, and then I was a failed founder. Actually, Technical Integrity, who's sponsoring this event, bought my startup, so can vouch that they are pro women in tech because it was a feminist startup. Good for them. And that's actually how you get into product management, is that you fail at everything else. And the more jobs you failed at, the better you are, because that's how it works.
Success in a startup world.
Technically, yes. Ended it like $1 in the black. Great. So raise your hand. Everyone raise your hand. Great. And then lower your, wait, actually, how do I make this non-judgmental? Put your hands down. Wait, now raise your hand if you know what an MVP is. Okay, almost everyone. So we'll do this part really quick. It's a minimum viable product. So you do the least amount of work you can to assess whether the thing you're building is something anybody wants, and you need to observe actual behavior in order to assess that. There is much hatred of MVPs out in the world. This is a common joke that I've stolen and misappropriated for my own use. Minimum viable pancake. Can we sell pancakes? Learning, no demand for pancakes. Sometimes MVPs work, sometimes they don't. But here's an example of an MVP working really well. Has anyone heard of Zappos? Mm-hmm. Great. Love that everyone's participating in the hand raising. Yeah, keep it high. So Zappos is wildly successful, and they started with Tony Hsieh like selling shoes out of his house. Like he put up some pictures on an HTML static site. If someone tried to buy the shoe, he would literally walk to a shoe store, purchase the shoe, go to the UPS store, and mail it to them. Like there was nothing technical happening on the back end. And that, my friends, is an MVP. and that's how you become a millionaire also, is shoe hustling. So very minimal coding, but you get to observe actual behavior. Turns out shoes are things that people want to buy. So what's a waffle? WAFL, W-A-F-L, stands for well-architected, functionally limited. So basically you write code you're proud of, but you add back one feature at a time. Raise your hand if you've had to deal with a startup's MVP code before. Keep your hand raised if you loved it. That's what I got. Okay, so let's talk about why we did this. Actually, let's not, because we're going to talk about that later. I was too ready to rant there. So, how do you make a waffle? Well, you bake from scratch. Please, someone laugh at the non-GMO code one. I gave this talk in Denver and nobody got it. Fulbrights, anybody? Any laughter? Good. All right. So the idea with a waffle is that you're writing actually good code that can scale. And like if you work at Circle CI, like millions of users could hit the website and the site won't crash. That's the idea. So you're writing really, really good code. Don't try and fix your old code. Just throw that stuff out and start over. Number 2, add back one thing at a time. So as we were creating our waffle, which I'm going to talk a little bit more about in a second, there's like 78 pieces of information on the old UI when you hit the basic job page for Circle. We added back one piece of information and like 80% of people were like, oh, this one's pretty nice. So like what we're doing here is trying to figure out what we actually need on the page as opposed to the stuff that like somebody threw on there over the last 6 years and who knows why they did it or if anyone is using it or if it's relevant anymore. So we added back one thing at a time. We collected tons of feedback. The one thing we added at a time would often get some negative feedback and also get some positive feedback. But some of the most important feedback we got was, why haven't you added back test summary yet? Or why haven't you added back the favicons that change based on the status of the job? And that feedback is really important because if someone is missing it enough to actually take time out of their busy day as a stressed out developer to type in, where is my favicon? They really care about the favicon. So that's probably something you should add back. We didn't actually have to add everything back. There's tons of stuff that no one noticed is missing. Stuff we thought was really important. And it turns out if you just don't add it back and no one notices, then you can just stop coding it. So it's great. But so we put our new UI out there very, very early. We allowed beta users to opt in back when it was still one piece of information. We got feedback either way. Some people yelled at us. Some people called us dumb on Twitter. And that was great because that gave us the data we needed to know what to build next, if anything. So when should you build a waffle as opposed to an MVP? So a really good important thing here is to have product market fit. I think something like, is it 93% of startups fail? Something like that. So you probably don't want to spend $2 million building a front end if you don't know if anyone's going to buy your burnt pancakes yet. So if you're pre-product market fit and no one is paying you, don't bother. Just write some MVP code because you're probably going to throw it all out and completely change direction 68 times. Take it from a semi-failed startup founder. Also, you've accumulated enough tech debt that iterating is really a challenge. Do any of you use Circle CI? Okay. You might have noticed the front end hasn't changed in a long time. That's because if you change like one little word from like yes to no, like the most minor ridiculous HTML change that you would think would take 14 seconds, the entire site crashes because our front end is spaghetti code. It's gone on too long. People kept trying to fix it instead of starting over. It got worse and worse and worse. We can't iterate on it because how are we supposed to iterate if it takes a week to make a minor wording change? It wasn't that bad. I'm exaggerating, but I'm a dramatic person. And so that's a good time to consider a waffle is when MVP code is just not going to cut it for you anymore. And also your app is too feature rich, hence like the 78 features that it turns out people only use 3 of them. So our story here. So before my time at Circle CI, they tried this massive back-end and front-end project called Janeway that tried to solve like all of the problems of the whole app at the same time. They spent a lot of money and it failed, as you might imagine. So then they thought, okay, how can we do this one piece at a time? Around that time, this cool product manager with like really good pun jokes showed up. And so we formed a new team called the X team, short for experienced team, but secretly because we're superheroes and we like to like sign off our calls like this, So our charter was just to overhaul the UI. Like, don't bother with any back-end stuff. Just make the UI something we can iterate on and that users don't hate. It took us a couple months to get to the first point where we could show users anything. It turns out if you overhaul the front end and the back end is still pretty messy, that it takes some time to sort all that out. But we got it out there. We started collecting feedback super early. Again, got lots of angry tweets, and that's great because that's feedback. It took us another 6 months to get through just all the jobs to be done, is what we call it. So all of the core things that you need to do on Circle CI were covered in some form or another, some more delightful than other. And we believe we will wrap up this project in approximately February if we're good. So 1 year to overhaul a UI, which is pretty exciting. So here's some things we've learned along the way. So again, before my time during like the infamous Janeway project, they created these like extremely perfect, down to the pixel, perfect designs of like what the new UI should look like. And here's the 3-dot menu here, and here's the queuing thing here. And it included like tons of details that nobody needed, that we found that we never even had to build, and some stuff that we threw out there and users were like, why is all this shit in my way? Like they really didn't like some of the stuff that we were starting to put out there. And so it's not that like goals aren't wonderful, but it is that like spending a lot of time to get a design pixel perfect before you've written a line of code is not the best way to go about things. It's not the startup approach. It's not the user-centric approach. It's best to just, we found like, get a high level of direction we're going and then use user feedback to iterate along the way rather than trying to make something pixel perfect according to a design that was always 100% hypothetical. Number 2, everyone will complain. OMG, are you guys nuts? LOL. That was one of my favorite comments that we've gotten in our feedback. We've gotten actually 6,000 people have written in to our in-app comments. So lots and lots of data. This week, someone from Brazil said, you are a bunch of, I think the word was cachara. We looked it up. It means drunks. So along the way, someone said we should fire our UX designer, which she thought was hilarious. She's actually the best. And so, you know, we got lots and lots of comments, but as I mentioned, like constructive comments, if any of you are giving comments, like saying like you're a bunch of drunks, that does actually not help a company. Saying like, hey, there's a lot of white space around this. I think you could be condensing this information so that I can consume more at the same time. That's really helpful. So now you'll all be better feedback givers. But also the people who did chime in and explain what they liked and what they didn't like really helped us to know what to work on and how to work on it, etc. Incidentally, we give $50 gift cards if you do a 1-hour user session with us. Mike's done one. So he knows I pay. So if any of you would like to talk about that, let me know. Number 3, well, we started succeeding with the whole waffle thing. And then all of a sudden we got a lot of attention. And then our little like under the ground team that no one thought would succeed was like, hey, can you teach everyone to do this? And we found ourselves sort of inundated with like people wanting to help, people wanting us to help them. We got distracted by, we built a design system. We like spent a bunch of time building dev tools for teams to get onboarded on this new UI train we were starting that no one actually used. And we planned even more before we just stopped doing that. And so once you start succeeding, lots of people want to come in, and that's wonderful to get other people on board. But I think what was core to our success during the quarters we succeeded versus the quarters we didn't was distraction, was level of distraction. So having one goal, one guiding goal along the way, one North Star that you're heading towards, and getting rid of as many other distractions for your team as you can is really helpful. Every developer's like, yeah, been there. Agree. So, and then number 4, have a super positive team culture. We make lots and lots of jokes. We make fun of ourselves. We laugh when people call us drunks. And that's really important to us, having a great team.
So you didn't fire the UX?
No, she's amazing. We did not fire her. And actually, we tweeted back at that guy and was like, hey, thanks for the feedback. Do you want to do a user session with us? And he felt so bad. And I was like, I was having a really bad day. It was so nice. We're all friends now. It's $50. Power of a little kindness. But it really does help the team hang together, especially because, as you all know, software is sometimes really stressful work. And in a long-running project like this one, with a lot of questions asked along the way, it's important to support and be there for each other. So that's very important. That's it. I talked really fast. Questions, comments, rants about MVP code, rants about Circle CI.
So you talked about, these are also almost complementary tools. So if I write an MVP and I get it out the door and I achieve product market fit, now I can go back and do this.
Correct.
Tell me more about the well architected. So what, did you find yourself spending more time writing architecture or architecting system? Because you're already product market fit. And spending less time integrating features because you were doing them one at a time.
Yes.
Right? I'm confused where the well architecting fits in.
Yes.
Because if I well architect my MVP,
right,
then I may not necessarily need this step.
I'm suddenly like, oh man, I wish one of my engineers was here. So I'm not the best person to answer that. What I can say from what I know and my perspective is we couldn't get anything done in the old UI. We could move really quickly and add new features in in 14 seconds in the new UI. And so whatever we did to set that up nicely so the whole system played nicely and things got out the door really, really quickly in snap iterations and with no crashing the website every 14 seconds along the way. That's the well-architected bit.
Because your engineers knew where they were going.
Yes.
They're like, we're going to get 72 features. We know what that looks like. We're going to rewrite. And everybody knows that rewrites fail because the second system syndrome, you screw the first one up, you're going to screw the second one up. I'd love to talk to an engineer. Why didn't this get screwed up as well? Was it a different team? Because, and they always say, well, if you want microservices and you wrote a shitty model, you're going to write shitty microservices if it's the same engineers because they just don't necessarily have the skills maybe to well architect things. I'd love to find out why did this work differently from the original spaghetti code. Well, but she said if they can add features in 14 a day.
Yeah.
You've obviously done something to set that up.
It is an entirely different engineering team. So the engineers that we have now were all hired within the last year. And I wonder if that did carry in a different mindset. Most of the folks who are on this project have been on horribly failed UI projects at other companies. It seems like there's a lot more failed UI projects than successful ones.
Don't get me started on those.
Can I get you started on CSS instead?
I'm okay. But it would be interesting to find out from the engineer, why did this succeed? Because we hear so many rewrites failing in the industry. What did they do differently that will allow them to succeed? Which would be an interesting engineering talk if one of your engineers did that. After we
should fly one of them out to the next Boulder Ruby, and then we can grill them on it.
We can do remote.
That's true too. Dan, I think you had your.
I just want to say, I wonder if some of it is that they might have moved quickly that first year after they started the MVP. And so they were moving quickly there, and then you have 5 years of cruft, and then you encounter that, and you have to move slowly. And now you've thrown everything away, and so you can move quickly again. In 6 years, who knows whether you'll be moving quickly or slowly, right?
Oh, yeah. Yeah. Probably they'll have to do another waffle in 6 years, but we'll be a different company in 6 years.
Exactly.
So
sure.
It's sort of a natural evolution of things. I know that the main thing that caused it, from my understanding, was that we started with an older system that only did 2 things, and then as we added more things to it, they weren't integrated with the original system well. It was like adding an addition to the house, but that's wood and this is brick, and so it sort of Frankensteined its way along. And that was part of the problem with new things making the website crash, was that variables would be named the same thing, or you wouldn't realize that the toilet in the main house affected the sink in the addition. And that's my best explanation from the less technical standpoint.
I mean, Martin Fowler has a graph, I think, of like velocity versus architecture. And he says there's this inflection point. If I do no architecture up front, I go really fast and my velocity levels off. But if I do architecture up front, I'm slow, but there's a point where they cross. And what I want to be is I want to go no architecture until I get there, and then I want to switch lines.
Right. Jump on a moving train.
Like make that left-hand turn and be like, now it's time for architecture. We're just going to keep slinging Java code as fast as we can.
Sure.
You end up on that other line, and then it's way too late to make that turn. Which like you got to back all the way up.
Right.
And yeah, and I love your point of who knows where this is going to end up. It's you're a year into this. Awesome. We can all add features fast in a year on the code base. In 5 years, are you all right back at that place where you're slowing down? Because you're on that fast curve again. You like reset the curve back to the beginning. I love the point of adding features in one at a time. I think that's like the piece where it's like, oh, we added 6 of them. Now we're done. Like we don't have to add the other 66 features because nobody's asking for that. And that's once you've got product market fit and a cohort of users that are willing to give you that feedback, that's super powerful. Because most startups don't even have that cohort. Like the owner, like the founders are making shit up as they go, and they're like, we need this, and they're like, why? Because somebody's willing to pay for it.
I talked to this guy.
Someone's willing to sign a contract and we add that feature, let's go add that feature. There's like, that gets you like $100,000 in revenue and it costs you $200,000 a year to support it. Because, but so I love that point. Like, I think that point for me was like, that's awesome because now I have less code.
Yeah. Yeah. Not everyone says I'm a genius, but maybe some do. All right, there's a couple hands in the back corner over there.
Yeah, so you mentioned a design system. Was that part of the plan up front or something that happened organically? And do you think that is, talking about a UI project, can you attribute some of the success to that?
Oh, the design system. This is an emotional trigger. This was a point of contention between various factors of the Circle CI team as to whether the design system has helped us speed up at all relative to the time we put into it, because we just don't have that big of an app. Like it's like 12 pages. And so having a design system is extremely useful when you have a complicated UI with lots and lots of pages, and the components might change from this page to this page to this page to this page. And to the point about architecture, takes more time up front and then helps you accelerate along the way. If that's going to happen for us, we're 2/3 of the way, no more than that, through this project, and it hasn't helped us yet. So it's a point of contention that I shouldn't speak more about in case someone watches this video from my team.
Because we created a design system, and now our management team has promised a single-page app in a quarter. So I'm thinking those are unrealistic expectations.
I'm not sure.
Next question.
The system helps you with speed some of the times. I think it's more consistency. Like I've seen design systems help with consistency, but inevitably, if you don't know what you're building, your design system's not going to help you because you might not have that widget, and then you got to go build a widget.
Yeah.
So I think I would.
Well, they built like 50 view components up front, and are like, this is what we're building the UI across products with now.
Right, and now you've done big upfront architecture, and nobody knows if those widgets are what you need, and they think they are, but now we're going to have to tweak that widget. Now it's going to take us 4 weeks.
Hey,
good luck.
You tell me what you learned, I'll tell you what I learned.
I've been trying to be very vocal against this and against these timelines, and everyone's looking at me like I'm crazy. And I'm like, I don't think I'm that crazy.
I think you should do a follow-up talk in like 6 months.
Sure.
3 months.
We're somewhat
different in that we have 4 years worth of code, and we are now. We kind of looked at our code and said, well, what do we hate about our software, as engineers? And we're now going through and I guess I call it like, we're an oil tanker now. We have a lot of legacy code. And so now we're turning the oil tanker. We're no longer a speedboat where we had 5 pages and it's like, oh, we want that new feature. Let's go over there. We have to move. So now we are implementing a design system. We have a designer. We're implementing components in Angular that are reusable, and we are actually seeing benefit from it. So, oh, there's a table view. That looks just like the other table view. We can use that, reuse those components, and we have the same design. So I think it's a trade-off for sure, but it's almost like you need to get to the point where it's like it's painful and you're willing to take that step and say, okay, we're going to take a little more time to really look at our UI and decide where we're going to redo it and what is the common things. And now that we've had some background, we can kind of say, oh, look at all these things that are the same. They do work the same. We want them to work the same, so we can build a component or build design around that and say we want it to look the same and act the same. So that's kind of where we're at now. We're in that turn, right? We're not there. We won't be there for a while, but we've made that decision to make that change. So for us, a design system works really well because we do have a lot of pages, a lot of functionality, and it's nice that it's common now. Our designer can just say, oh, here's a balsamic thing, put the table thing there, put the button thing there, put the button thing. You know what it looks like, go. And the developer's like, okay, I don't need a high fidelity mockup because I know what it generally looks like. And then when we get a page where it's like, oh no, this is something new. This is a new component. And we get, more high fidelity looks and click-throughs and stuff like that and go, oh yeah, now we understand what we need to build with an eye towards, can we reuse this in the future? So it is working for us in some way. Anyways.
I will say I'm obviously in camp anti-design system because in the chair that I sit in and in what I see right now from my perspective, I haven't seen it accelerate work.
Right.
However, I'm much more committed to learning here than to being right. And I wouldn't be shocked nor saddened if I was proved wrong. And a year from now, I come back and say, thank God for that design system because we'd be lost without it. It does seem to depend on the size of the app and how many pages you have to keep consistent.
I would agree. I mean, very small app, you're probably not going to get the benefit as much. When you start getting hundreds or many tens and tens of pages across multiple apps, and you want them all to look the same, that's where it seems to work really well.
An extraction of a design system, I think, is important than a creation of a design system because those tables are the same.
Yeah.
Where you're gonna end up biting yourself is
this is V4 of the UI.
You think this is the same, and it is for like a month and a half, and then it's not anymore, and now you got to go build a new component.
Yeah.
Where it sounds like
Ursula's had a comment.
Let's
exactly.
Yeah.
Go ahead.
I mean, just kind of building off of that too. I work as a consulting group, and right now I'm on an internal project with the flightiest customer we've ever had, which is our internal marketing team. I love them so much, but but they want different things all the time, and we do have all of our components and our views and all of that is separated out in a discrete code because they're like, we need a new campaign page. We need it tomorrow. We need it in 2 days. And I'm like, 2 days maybe, but we're only able to do that because we have all those different pieces, even though our website is fairly small, and it's a fairly small marketing website because they constantly want new little, they want a new ad campaign to go to a particular page that has these assets on it. Then I'm like, okay, great. We know what that looks like and we know how to do it. So it seems like if it's more of a static product, maybe it's not as valuable, but in a case where we have the good client, the customer or whatever, coming to us constantly being like, we need one thing very different, and we want to get rid of this other page in the meantime, by the way. Then being able to have something in place where you can just spit out a new page without having to sweat it too hard is really, really useful. So I think that's another area where design systems get really useful.
There's a question over there. I thought I saw someone else.
I had a comment on the concept of why the MVP sometimes fails and the waffle is delicious. Brett Brooks, I think, is the man.
He's winning so far. I'm trying to throw a few more puns in.
I brought my only one. I'm sorry. He wrote this book called Design, and one of the central tenets in this thing, making an operating system for the IBM 360, a brand new architecture that no one's ever tried to build for before. And one of the core concepts he brought to his team is we're going to plan to throw one away. We're going to burn one. When you're trying to build something new that hasn't been done before, you need that exploratory work. You can't anticipate what the finished product is going to look like. And you can't give yourself a solid architectural foundation without knowing what you're ultimately building. The MVP is exploratory. That's to figure out what your product is, what direction it needs to go in. When it's time to waffle, you know what you want to rebuild. You know what this thing is going to be. That sets you up with the knowledge that you need to build a solid architectural foundation.
Yeah.
Here.
Yeah. Toast it.
Something in front of customers to even validate yourself.
Right. It's like the architecture of your product, not the technical architecture. It's a similar concept. That's a great point.
You mentioned when you were talking about just getting distracted by success, seeing success, and then other teams were coming to you, wanting to make their own waffles, and they wanted you to make them tools to do that. So did you call them waffle irons?
Oh, he's winning now. Yeah, so let's talk about that a little more. It's so funny when they first, and I want to say it wasn't necessarily the other teams who were asking us to make them tools. It was upper level management who was like, empower the other teams. And then we immediately jumped into like, what does that mean? And suddenly we were a DevTools team. And I had a great mentorship copy with Mike.
Is this the top?
Yes.
Yeah, okay.
Who was like, oh my God, don't be like, get yourself out of the DevTools business as quickly as you can. Because it's hard to know when you're done. And it's hard to validate what would have been helpful in the first place when you're building something new. So here's what we learned. Here's some off-the-cuff lessons that I've taken away. The design system obviously evokes a lot of emotion, positive and negative. So that maybe that worked, maybe it didn't. Building other tools like, what was a good example? We were going to build a script you could write to set up your microservice really quickly. That was not helpful because we don't have that many microservices. There's like 3. So we would have spent more time writing that tool than anybody would have spent using it. There was some like Chrome finishing polishes that we were going to build and add to the design system such that other teams didn't have to. But by the time that those teams needed to use that special left-hand navigation that we built for them, it had been redesigned, so no one ever used it. So those kinds of things were not helpful. What was helpful is just being a good team member. Like what they really helped and like what they were actually aided by was our technical leads getting on the phone with them and just walking them through, here's how to get this set up, here's what we've learned, here's how to work with this and this and this. Like just an hour on the phone meant more than any of the dev tools that we built, as far as I can tell from my seat. And so when you talk about empowering other teams, I, now standing in the position I am now, am seriously, I would have strong questions about building more dev tools unless there was a very obvious business case and very repeated, like, oh, this is something that every team is already struggling with, not like a hypothetical, like, I don't know, maybe they'll struggle with it in the future. But like focusing it exclusively on things that are problems right now across the teams, and making sure that we are solving a very limited problem that we know exists.
I'd also be delighted to steer people away from the internal tools as a strategic agenda in a software company, because I'm now at a company that's big and has a bunch of internal tools teams, and they can't scale to meet the size of the company. They're a bottleneck for the deploy pipeline type of thing, and the business has got this idea that, well, these 6 developers should be able to keep up with the other 500. And y'all can do the math. That just doesn't work. We're underinvested on the internal tools because we think there's some leverage there, and it's not true. So,
right. Like Circle CI as a product is very centered on empowering individuals as a team.
Yeah.
Like that's a core differentiator between how our CI/CD system operates and Jenkins, which empowers a lot more of like a central stakeholder who makes the decisions and gatekeeps changes. We just don't have the tooling to allow that to happen intentionally. And so, like generally speaking, I have seen Circle CI empower individual teams. That hasn't been like a trend that people are gatekeeping, and that trend is working for us.
Right.
I'm agreeing with you.
Yeah. Yeah.
I would almost say that internal tools are an anti-pattern. They create coupling between your teams.
Yeah.
Everybody wants microservices, and they want to reform their organization so these teams can move independently.
They need
I've
an
got this
independent.
central team that is coupling team A to team B through
Yeah.
some dependency.
Yeah.
Like now they can't move independently because now I'm doing versions. So it's this, it's the like, oh, we'll go faster. But if you start to measure it, you're like,
It's not
an hour on the
faster.
phone is much cheaper than having 6 people write these tools. And,
Yeah.
I mean, I would love to hear the scale that you guys are working with
Yeah.
for sure. Definitely a
they're-
different scale than
They're
how many
beasts.
engineers came?
There's 6 on the team. Oh, but across the company, I think it's like 80.
Okay,
Yeah.
so
Yeah.
much different scales. I mean,
Yeah.
do you want to say who you work for?
Yeah, I'm at New Relic.
So,
Yeah.
you know, a team
So,
that
I
is,
just
is
use
building tools. use like-
Nice.
We've got
Yeah.
we've got now 70-ish teams.
I was at Living Social for a while. We tried to build an internal tools team. And it just, we had hundreds of engineers. It doesn't work.
Yeah.
Everybody thinks it is because management thinks we're gonna go faster. I'm like, no,
Right.
we'll just go faster doing our own thing.
Because the management rationale is we'll have the people who are really good at this DevOps stuff build tools for everybody else, which is great. And I'll tell you, our guys are great. And there's 6 of them. Teach
And
the
when you
rest of the
ask for a seven,
company.
they're like, nope.
Yeah, a question for you, and I guess people generally around these questions is like when like how hard is it for you to justify like we're going to have this X team or whatever, right? Like how did you get buy-in for that? And like what, I guess, because sometimes there's a disconnect, I think, between like business needs and like what dev teams really want to do and then what like product maybe really wants to do. I feel like product is kind of the bridge between management and dev teams a lot of the time. And I'm curious how you like have navigated that relationship of like, no, we really need a different UI and you have to give us a year and you have to give me 6 people on this team to do it. And how that went.
We can turn off the recording.
Or conversely, how would you make the case to management? Hey, 6 people for 500 seems a little silly. Maybe we shouldn't do this.
I'm still working on that actually. Like
That's what I
because
would
I'm not quite in the place to make that pitch, right? I'm just, a dude with some experience, and I have the added problem that I'm in Boulder and they're all in Portland. Not all, but yeah, decision makers are in Portland. So it's a ASCII characters in Slack or how they're going to get this pitch, and it just doesn't quite land.
So here's the thing, like everyone at Circle has the best of intentions, and we're all trying to like move the rowboat forward. It's just that everyone's looking a different direction. Like, of course, engineering has a different perspective than the CEO about where we're going, because we're all looking at different things and coming from different backgrounds. So it is hard to drive that alignment, and I would say that's been a major battle throughout the life cycle of this project, is not only driving it once, but continuing to drive it when the same questions come up once a month along the way. And you're like, wait, didn't we talk about this in May? And so I would say it's constant over communication. I think that the way that this project actually happened is that it was a problem for both product and engineering, because engineering couldn't move in the code base. And then at the same time, product couldn't get anything done because engineering couldn't move in the code base. So the fact that it became such a conflagration for everyone was what brought the people together around the campfire of overhauling the UI, is that it served both needs. That also created some tension, because the goal of the project, if you asked a product person, was to make a better user experience. And if you asked an engineer, was to get the code base replaced so that we could move in it. And that was the idea of the waffle, is that we could do both of those at the same time. Now, depending on who you ask, they might say that worked or it didn't. But we're pretty close to done. And I like to think that we'll look back and say that it did. But, ask me in February. But yeah, I'd say it was because both sides felt the problem. And then I think it's been just constant, continual communication ever since. And I would say that's actually a huge fault that I had going into this project, was that I hadn't been in this role before. I'd been a founder where I called all the shots, right? And so obviously everyone trusted me. And that doesn't happen when you step into being sort of like the newest kid on the block. And I think that I should have done a better job up front of over communicating what we were doing and where we were going and making sure that both sides of the table were aligned on what the number one goal was. That was a huge, huge lesson learned. So, yeah.
No, that's super useful. Yeah, just like always for like consultancy work, you have different clients and different expectations, and you're working with different people. Are you working with the product person? Are you working with like their CTO? Who knows? And that communication thing. I don't know. I was just like, I'm glad to hear your insights on that.
Yeah. I think when we first started the project, our strategy was like run undercover and hope no one notices us. And actually that worked pretty well to get a lot of stuff done in the first quarter because just no one asked any questions. But then we did a lot more product work than perhaps other factions would have preferred. And so the best thing I think we've done in the last 3 months is that we started having a EOL meeting once a month with the 2 lead stakeholders from product and engineering both involved, so that we can say, this is what we're working on to achieve this goal. And if one party believes that's not what the goal is, then that's where we can talk about it. And so it's not a telephone game of like, but Matt said, just get people in the same room as quickly as possible, I think. How long am I supposed to talk for?
You have another 3 minutes.
Oh, thanks.
So, or we can end early.
I had a quick one. So you mentioned that when you first started this process, your back end was a little janky and you had to work around that. Do you think that waffling the back end at the same time as front end would just lead to a dumpster fire or
Kitchen fire.
Kitchen. Oh.
I should have said that. I was waffling.
Grease fire.
Just get better and better. Just trying to figure out if I could work a pun into my response, and it's not coming to me, but I'll keep working on it and take a stab at this in the meantime. So can we waffle on the back end at the same time? So that is kind of what we tried to do with Janeway, was like, let's change the front end and the back end at the same time. And that ended in sadness. And so I think it has become very important, like a huge lesson learned for our company is like, make things independent from each other. Like making like my team dependent on a back end team did not work out. And so having like one team stable at a time, or at least not affecting us at the same time, was extremely important. There are teams working on the back end, but not in such a way. Okay, there has been, I think, 2 times where someone's dropped into our Slack channel and been like, hey, we're going to change this API endpoint. You might want to look into that. And it has affected us, but that's been minor. It's been like very minor, quick changes as opposed to like major other dependencies that we need to rely on. So I would advise against that. Is the syrup that I'll stick that together with.
On that note.
That sounds like a recipe for success.
All right,